You should have had plenty of time before lunch to finish these problems, so I'm hoping we're ready to go for this. Where's my pause button? Here it is. So, for problem number 1, let's look at that first. A little fuzzy looking to me. Yeah, that's upside down. That's a little bit better, not much. So you can see my answers over here. You needed to get a radius, your r, of root 13 over 6. Everything depended upon that. And then my work up here, what I did is I said sine is y over r, but since they're fractions, I did y times the reciprocal of r. I simplified that, and then I did the rationalizing. I left this step here because I knew when I came down here to my reciprocal functions, this would be a lot easier to do the reciprocal of than these guys, than the final answer would have been. Any questions on number 1? Yes, sir. Okay, the tangent is your y over your x. So I'm not going to do 1/3 divided by 1/2. I'm going to times by the reciprocal. So 1/3 times the reciprocal is times 2 over 1. And to multiply that, it's just numerator times numerator, denominator times denominator. Anybody else? All right, my work for problem number 2. I very much like to figure out where my coordinate points are, and then I go from there. That's just, to me, what's easiest. You don't have to do that. If you can look at sine of 7 pi over 4 and say, you know what, I know sine of pi over 4 is root 2 over 2, and just think about the correct sign as in positive negative, you're more than welcome to. Same thing with cotangent. If you know the cotangent, or if you know the tangent is root 3, cotangent is then root 3 over 3, then you can think about the positive or negative of it. Yes, ma'am? For B, so 2 pi over 3, I know my pi over 3 coordinate is 1/2 root 3 over 2. But 2 pi over 3 is going to be in which quadrant? Quadrant 2. So that means it's going to be negative positive. Then in order to finish that, cotangent, you can think about that as x over y, or you can think about it as the reciprocal of tangent. But if I do x over y, I will do negative 1/2 times the reciprocal. Those two cancel out. I have negative 1 over root 3, and then just rationalizing it. Okay? Anybody else? That leaves us with problem number 3. That's where I used all this stuff for. Here, so you can see the answers pretty quick and easy, and then we'll go over it. This guy shows up a heck of a lot. Okay. All right, so I'm going to scooch it up so you can see the full-on work there. And I used my geometry writing for this, but if you wanted to say, let's call that angle A, that's what I was doing here. And I can call that angle B. That's what this is here. So if you choose to solve straight up for that angle right in there, the only way that you can do that and know that you have faith in your answer is law of cosines, because law of cosines will deal with obtuse versus acute angles. You don't want to do that? Fine. I didn't want to do that. I figured I like law of sines. It's a lot easier. There's a lot less going into it. So I did law of sines for this angle. And then I said, okay, subtract it from 180. 45 minus this to get that. All right. Any questions? We're really putting an emphasis in here on your cumulative review stuff, simply because that's kind of been the weakest of every section of every test that you've done. I want to kind of keep that from happening. the next time around, which is coming up next week. You probably want to know exactly when next week. That might be an interesting thing to say. So your test, because this is the last lesson, that's statistics. You are not in statistics. You are in pre-cal. Your test is gonna be next week, Wednesday. Because today's Thursday. I'll see you Monday, we'll review. Wednesday, we'll test. All right? Okie dokie. Let's go! Homework questions. Yes, ma'am. Number 6, the one that had a typo in the answers. So number 6 is a really great one for us to work through no matter what, because of those fractions. 6 started off with 1/3 negative 1/4. If I'm going to find the radius for that, my radius squared will be 1/3 squared plus a negative 1/4 squared. Don't forget, a negative times a negative, well, that's always going to be positive. So I have r squared is 1/9 plus 1/16. So far, so good? Okay. The smallest, you can do this a couple of different ways. How do you want to find the common denominator here? What's the common denominator? 30. Well, 32, 16 goes into, but 9 does not. How about just taking the easy way? To me, the easy way is to times this by 9, this by 16. That leaves me with r squared to be 16 over 9 times 6 is, okay, so 144. Thank you, plus 9 over 144. That leaves me with 25 over 144, and I am extremely happy right now because that's r squared. Those are both perfect squares, so I'm happy. It's not always going to make me happy, but when it does, yay. What's the square root of 144? 12. So there's my radius. Then we work through our angle. Please, please, please. For this guy, you were very lucky. They gave you the actual page where they said the sine of the angle. They went on and on through that. You always have to follow your ratio with an angle symbol. You can't just say sine equals. So sine is going to be y over r. So negative 1/4. I'm not going to put the divide by a fraction. I'm going to times by the reciprocal. And always, ladies and gentlemen, make your problem easier before you make it harder. 4 goes into 12 3 times. So the sign is going to be negative 3 over 5. And then you would continue carrying that through for the rest of them. Beyond the radius, were there any specific ones that you would like to see done? Yes, sir. Okay. Number 3 gave us the coordinate 2, negative 3. Is it safe to assume that you had your radius of root 13? Then you wanted one more time. Which ones? Cosine and secant. So cosine is your your x over your r. So 2 over root 13. That will rationalize to give me 2 root 13 over 13. You said cosine and secant. So secant is the reciprocal of that. I could flip this. That's a heck of a lot easier to flip because I won't have to rationalize it. So it'll be root 13 over 2. Should be positive. I make mistakes. He's okay. Anybody else? Any of those homework problems? Alrighty. So what I want everybody to do right now, I want every single calculator put away. If it's my calculator, put it back. If it's your calculator, put it in your bags. Don't even want you to be tempted to touch the suckers. The really, really good news about today, I'm not really doing anything different. This idea of terminal point trig is not changing. The only thing that might change is what quadrant, or how do I understand what quadrant I'm supposed to be in. The way I'm going to do this is I'm going to use, I don't even need this whole crazy quadrant picture. All I really need to know is that I have all students use pens that hopefully are not dying. All students take calculus. That's what I want to know. That is going to give me my quadrants to help me figure out how to solve this. You can even deal with this on a smaller page if you want to start going through and working that. Now, this first thing says sine is less than 0. That means, is sine positive or negative? If it's less than 0, it is negative. Which quadrants have a negative sign? T and C, 3 and 4. So these are the two quadrants that match this. This is telling me that my cosine is what? Positive. My cosine is going to be positive in which quadrant? 1 and 4. Pink and yellow make orange. Can you even tell that's orange? I think it's awesome. Can you see that? I think it's awesome. So the overlapping one, the one that works for both of them, is right here. What quadrant is that? Quadrant. Be able to draw a 4 because you're special. There we go. Q4. It's not even looking at that crazy big graph. I can do it again. And I don't care which way you want to do this. All students take calculus. All students try Cheetos. No? Cheetos are yummy. Boring. Tangent. What is tangent supposed to be? Tangent here is positive. Greater than 0 is positive. That means that I have to be, this is tangent is positive, where else is tangent positive? Quadrant 1. So if you want to just kind of ignore the others, you can say, hey, tangent is positive in 1 and 3. Then it says, what is this? Cosecant, which pairs up with sine. What quadrants have sine positive? 1 and 2. So if it's 1 and 2, then that means that these two are canceled out. Who's the only guy that's left? Quadrant 1. So you can think about that either way. I don't care. You can think about highlighting who meets those conditions, and your answer is where they overlap. Or you could cross out who doesn't meet those conditions, and your answer is whatever's left. I don't care. I want you all to try number 3 for me, please. I do recall telling you we had 6 problems today. Those are the first 3. Yay! Whatever way works for you, figure out your quadrant. Compare with your neighbor when you think you've got it. What'd you get? Quadrant 14. 32. Sorry, you're off by a couple. Quadrant 2. Any questions there? I'm just a very visual person, which is why I like to draw those. And depending upon what I have, if I have really pretty highlighters, I'll do that one. If all I have is a pen or a pencil, I'll do those. I don't care. And if you can do it without that, great. If you can look at this and say, okay, tangent is going to be negative in quadrants 2 and 4. Secant, which is the cosine, is going to be negative in quadrants 2 and 3. Those overlap. All of these different ways work. It's whatever works for you, works for me. Before we finish off, because we have 3 problems to do today, more. Before we finish it off, do a little bit of a refresh. If I give you a point, x comma y, remember that x squared plus y squared is equal to r squared. By the way, that symbol is a beta, or if you're from England, it's a beta. Not kidding, that's how they pronounce it. They're weird. So sine is what over what? Y over r. Cosine? Tangent. Then you've got those lovely reciprocals. No funky business going on. You all clear with what we're talking about here? I haven't thrown anything new at you. And I'm continuing to not throw anything new at you. I'm just going to say, all right, let's kind of deal with these same ideas in just a slightly different way. Go ahead and write down what I've given you here for number 4. These problems work exactly backwards from what you did last time. These problems start with one of the ratios, and you need to find all the others. Sine is what? Y over r. Then that means my numerator, y, denominator, r. Then you have this little dude right here. It tells me my angle is between pi over 2 and pi. Which quadrant is that? First one goes from, right, because we go 0, pi over 2, pi, 3 pi over 2, 2 pi. If it says between pi over 2 and pi, that means I'm in the second quadrant. My SIG ends, positives or negatives, what is that? Second quadrant is negative, positive. How do you think I can find this piece? Not special right triangles. Or you just don't even need to put it that way. You can just say x squared plus y squared equals r squared. Pythagorean theorem. I think that might have been what you meant to say. That means I have x squared. What is y squared? What is r squared? That means x squared is, what is x? And we have it's a negative 3 because of that quadrant restriction. Hey, sine. I know exactly what sine was. They gave that to me. Sine was 4/5. Woohoo! What's your cosecant going to be? 5/4. Nice and easy with that. Cosine is what over what? X over r. So x is 3, r is 5. Then there's the reciprocal. It's a weird accent. I don't know where that came from. What is your tangent going to be? Negative 4 over 3, yes. And then your cotangent. This is it. This is all we're talking about here. Are we okay with that? It really is exactly what we've been talking about. We're just kind of going from a different direction. Rather than giving you the coordinate stuff first, I give you one of the pieces. You find out all the rest of it from there. I think this is a heck of a lot nicer because fractions don't scare me anymore. If I have a fraction, I can just say the top is this number, the bottom is that number. Doesn't need to be icky. I want you to figure out what coordinate point goes with number 5. What is your coordinate point that goes with that? If you can tell by looking at just the general setup, you don't need to show me all the work for what you're missing. Especially if it's a nice Pythagorean triple and you recognize it right off the bat. Can somebody grab the door for me, Sebastian? Thank you, sir. I was wondering whose that was. Thank you for coming back for it. What is your coordinate for number 5? What's your coordinate? What is your numbers? Forget the signs. What are your numbers? 12 and 5. So 12 and 5 with a radius of 13. Then we have to think about cosine is negative and tangent is positive. In which quadrant? Quadrant 3. Do we have any questions on what I've done there? All right. Go ahead and find all your trig ratios. Here, I'll even give you one more piece. Watch. You're welcome. I did one for you. Because it's given. Go for it. You can do this one and then one more. You can handle this. Okay, let's take a look. Take a look. It's in a book. The answer's on the board. Questions for that? Any questions? Then I want you to work this last one through, start to finish, all on your own. Go for it. Here we go. Ready for your answers? You were born ready. What do you think? Obviously, you'll have a few problems with radicals in them. Yes. Cotangent is negative. Oh, it says sine's supposed to be. Thank you. So here, cotangent is negative. That should be, because it's positive. Thank you. Yes. Very good catch. Thank you for speaking up. That's the way that's supposed to be. So then this would be negative, negative. Those two are positive. Thank you. Don't question yourself so much. Sometimes I'm a dork. Okay, I'm a dork a lot of times. Anybody else? I want to point out my mistakes. I'm a flawed human being. Contain your excitement there, Connor. Don't. Just hold it in. So you guys have your classwork. It is the back side of your homework worksheet. So take those out and work on them. When you're done with that, turn it in. And I'm making your homework big on the board. All right, let's get to work. That's it.